Hello everybody, Mr. B here again for another fractions video. This is video 9 about mixed numbers, more properly called mixed numerals, but I like to call them mixed numbers. Anyway, let's start with the idea of improper fractions. Remember that those have a numerator that's greater than or equal to the denominator. And because of that, the value of the fraction is going to be bigger than or equal to 1. So when that happens, we often express the number as a mixed number in mixed number format, mixed numeral format. What does that look like? Here it is. So you've seen numbers like this. You see 2 and 3/4. The 2 is called the whole number part, and the fraction is the fractional part. 2 and 3/4 means 2 plus 3/4. So we can write 2 and 3/4 equals 2 plus 3/4. So what is the improper fraction equivalent of 2 and 3/4? Let's just look graphically at what this might be. So we've got 2 for the whole number. That means we have 2 whole ones. And the fraction part we're splitting up into 4. So let's split up those whole ones into 4s. And then we've got a third pi, but we're only keeping 3 of the quarters. So we have 2 full ones and a 3/4 one. If we add this up, we've got 4/4 plus 4/4 plus 3/4. We've got a common denominator of 4. We're going to get 11/4. Or we could just use the definition. If 2 and 3/4 is 2 plus 3/4, let's add these up. So we need to write 2 in another as an equivalent fraction with 4 in the denominator. First of all, 2 can be written as a fraction as 2 over 1. 1 divides into 2 2 times. Okay, then we have the plus 3/4. Let's get an equivalent fraction of 2 over 1 with 4 on the bottom. So 1 goes into 4, 4 times 2 is 8. I hope it makes sense. 4 goes into 8 twice. That's why 2 is represented by 8/4. So we get 8/4 plus 3/4, and that's 11/4, just like we got before. Okay. There's a quick method. Instead of using that addition method like we just did, which is totally valid, people have come up with this quick way of doing it. It's based on the addition method. So the numerator of the improper fraction is going to be the whole number part times the denominator of the fractional part, plus the numerator of the fractional part. And the denominator is going to be the denominator of the fractional part. So here's one. We have 3 and 5/8. The directions say take the whole number part, this is the numerator, and multiply by the denominator of the fractional part. Then you add the numerator of the fractional part. And the denominator of the improper fraction is just going to be what we had as denominator in the fractional part. So to reiterate, we're taking these two numbers, the 3 and the 8, the whole number part and the denominator, and that's giving us this product here. And then the 5 is coming from this numerator here. And then the 8 denominator is going to go here. So what do we get? 3 times 8 is 24 plus the 5 over 8. So essentially we get 29/8. That's the improper fraction for 3 and 5/8. I hope this makes sense. Remember in that graphical picture, we had the number was like 2 and 3/4, right? So we had 2 whole number part, 2 wholes. And that's what this 3 times 8 here is. We've got 3 whole pies and we're dividing them up into 8. So we're going to have 24 pieces, 24 eighths from those 3 whole ones, and then we have an extra 5 eighths. So you can see that we're going to get 29 eighths. Let's do this again, just to get good at it. All right, where is it? Oh, I hit the wrong button. There it is. So what do? We take the whole number part, multiply by the denominator, add the numerator, and then we get the the denominator of the fractional part. You see where I'm getting those, the 5 and the 3, and then the 2 from the numerator, and then the 3 from the denominator. So we could do this addition in our head. It's 5 times 3 is 15, plus 2, that's 17, and the denominator is 3. So there's another one. Okay, let's move on here. We'd like to also convert improper fractions into mixed numbers. So how do we do that? A fraction is essentially a division problem, and that's what we're going to do. We'll use long division on the improper fraction, and the mixed number will basically be made up of these things. The whole number part is going to be the quotient we get, and the numerator of the fractional part is going to be the remainder, and then the denominator of the fractional part is going to be the denominator of the given improper fraction. Okay, so let's try this on 15 sevenths. We're going to divide 7 into 15. I don't know if you remember your long division. You may want to look this up in like a pre-algebra book or something. There's, I'm sure, sources on the web that can help you too. So 7 goes into 15 twice, and then you multiply 7 times 2. You put the answer underneath, and then you subtract. 15 minus 14 is 1. This 1 is the remainder. That's the remainder. And the 2 up on the top is the quotient. So the rules, I'll raise it up here. The rule said the whole number part is the quotient, so we get 2, and then the fractional part, the numerator is the remainder, 1 over the denominator from the original improper fraction. So the result here is 2 1/7. You could check your work too. 2 times 7 plus 1 is 15 over 7 using that quick method. Okay. Let's do it again. So here we've got 83 being divided by 24. Let's see, 24 is close to 25. If we multiply by 3, we get 75. I think 24 goes into 83 about 3 times to start with. So what happens when we multiply there? We get 1272. Then you subtract, and we're going to get 11. That's our remainder. So what's the mixed number? The quotient is 3. That's the whole number part. The remainder gives the numerator, and the old denominator stays. So there's the new one, 3 11/24. You could check by multiplying 3 times 24 plus 11. Do you get 83? Okay. Next, let's add and subtract mixed numbers. So method 1 is pretty straightforward. To convert, to add and subtract, we're going to first convert to improper fractions with these mixed numbers. Convert them to improper fractions, then do the adding or subtracting, and then if the result is an improper fraction, we'll convert it back to a mixed number if we want to. Okay, so let's try this. I'm going to use the quick method to get these improper fractions. So the first one, and I'm going to do it in my head now, right? I think we've done it enough. We multiply 3 times 8. That's 24 plus the 5, that's 29 eighths. I don't know, maybe I shouldn't. Maybe I should write it all out so everybody can see it, because you just are starting to do this. 3 times 8 plus 5 over 8. And we're going to take away 16 in the bottom. But what do we get in the top? 1 times 16 plus 3. So what do we get? 29 eighths. Right? 3 times 8 is 24, plus 5 is 29. Minus 1 times 6 is 16, plus 3 is 19 sixteenths. Now we can't subtract yet. We don't have a common denominator. What is the LCD, the least common denominator? How about 16? Right? We can create 29. We can rewrite, get an equivalent fraction for 29 eighths with 16 in the denominator. What is that? 8 goes into 16 twice. 2 times 29 is 58. So this becomes 58 sixteenths minus 19 sixteenths. So what's 58 minus 19? We have to borrow. We get 9, we get 3. 39 sixteenths is our answer. All right. And then we said we could convert. That's an improper fraction. And if we want, we could convert back to a mixed number. How would we do that? Well, we have to divide 16 into 39. We know 16 would go in twice. 2 times 16 is 32. Subtract is 7. So this is really 2 and 7 sixteenths. Okay, so just to reiterate, we take our mixed numbers, create improper fractions from them, get a common denominator if needed, and result was an improper fraction, and if we wanted to, we could get a mixed number. All right, let's go to method 2 here. Method 2 is where we work on the whole number parts and the fractional parts separately. So we add or subtract the whole number parts, and we add or subtract the fractional parts. The only thing is, when we do that, we may have to carry or borrow. I don't know if you remember those terms from addition and subtraction of whole numbers, but the same kind of thing can happen here. Okay, let's see what this looks like. We've got 3 and 5/8 minus 3 and a 16th. I think these are the same numbers, right? But basically, it's like saying we've got 3 minus 1, and then we also have 5/8 minus 3/16. So we're adding, the whole number part plus the fractional part. But we're subtracting. So we're subtracting the whole number parts, and we're subtracting the fractional parts. You can see we still need to get common denominators here. 3 minus 1 is 2. And then what do we have here? 5/8. We need to get this in terms of sixteenths. 8 goes into 16 twice, times 5 is 10. You can see we're getting the same answer as we got before, 2 and 7 sixteenths. But we did it by just working on whole number part and fractional part separately. Okay. We could also, this is very convenient, use a vertical format. I'd like you to see how this goes. So you put the numbers over one another. The whole number parts are over themselves, and the fractional parts are over themselves. We still need to get, of course, a common denominator, but the fraction part, just next to it, write the new fraction with the equivalent fraction with the right denominator. So we know we want to go to sixteenths. 8 goes into 16 twice. 2 times 5 is 10. And then I cross out the 5/8 because now we're replacing it with 10 sixteenths. It's equivalent. Then you do the subtraction. 10 minus 3 is 7. So we get 7 sixteenths, and 3 minus 1 is 2. So that's the vertical format. Let's use vertical format again in this case where we're adding these mixed numbers. So 2 3/4, and then 3 11/32. We're adding those. We need to get a common denominator. We could convert the 3/4 into 30 seconds easily, right? 32 is our LCD. So 4 goes into 32 8 times. 8 times 3 is 24. Okay. So we'll cross out 3/4 because now we have 24 30 seconds. Let's add the fractional parts. 24 plus 11 is 35. And the denominator is 32. 2 plus 3 is 5. And, you know, this is interesting. The fractional part is an improper fraction. It's bigger than 1. We really need to carry that 1 over to the 5. It's easiest to see if you write 35 30 as a mixed number. So what is that? It'd be like dividing 32 into 35. It goes in once. 1 times 32 is 32. You subtract and you get 3. So this is really 5 plus 1 and 3 30-seconds. Now you can see we have 5 plus 1. 1 is a new whole number part when we break that 35 30 down. So the answer in cleaner form is going to be 6 3 30-seconds. Okay, you get that? Sometimes people just go, okay, we've got 35 30-seconds. They cross out the 35, take away 32, that'd be 3, and then cross out the 5 and add 1 to make 6. But this is maybe a nicer way to see what's going on. Okay, let's do this subtraction in vertical format. This is going to bring up another issue. So we're subtracting 3 5/6 from 8 1/3. We need to get a common denominator. What is that common denominator? 6. 6. So 3 goes into 6 twice. 2 times 1 is 2. Okay, so we have 2 6 as an equivalent fraction to 1/3. Now we have a common denominator, but we have another problem. We're trying to take away 5 from 2. We don't want a negative number. 2 6 minus 5 6 would be like negative 3 6. So what we need to do is borrow. We need to borrow from the whole number part and add it to the fractional part. So let's say we borrow 1. The 8 would become a 7. But then how many sixths is 1? Well, it's 6 6. So we have to add 6 to the numerator here. So our fraction is really 8 sixths after we've borrowed. I'll cross that out because we have 8 6. So we had 1/3, we got 2 6. We needed to borrow, we added 1 to it, but 1 is 6 sixths. That gives 8 6. Now we can subtract. 8 6 minus 5 6 is 3 6, and 7 minus 3 is 4. Also, 3 6 is not fully reduced, so we could write this as 3 goes into itself once and into 6 twice, so this is 4 1/2. What do you think of that borrowing thing? Maybe I should write it one more time and show what happened. So we changed 1/3 into 2 sixths. Then we borrowed, and maybe I should write it like this. That's like adding 6 sixths. That's 1, right? That's the 1 that we add to the 2 sixths. That's where I got the 8 sixths. Okay, I won't do the rest. We just did it here. Okay. Last subject, multiplying and dividing mixed numbers. In this case, we don't have two methods. We have to convert them to improper fractions and then do the multiplication or division. And like before, if we get an improper fraction as the end result, it's sometimes desired to get a mixed number from that. Okay. So let's use the quick method here. In fact, these are the same fractions we had before, but we're multiplying them. 3 times 8 is 24, plus 5 is 29, so we have 29/8. Then we're multiplying by 1 times 16 plus 3, that's 19/16. And I don't see any common factors to cancel here, so we're just going to multiply. You'd get out a calculator or something, or do it by hand. You're going to get 551 over 128. 551 divided by 128. There are no common factors here, but you might want to get a mixed number. If you divide 128 into 551, it'll go 4 times. Multiply, you get 512, and subtract, you get 39. So the mixed number representation is 4 and 39 128ths. Okay, I've got one more, a division one. I'm writing it like this. Could we write it as two improper fractions dividing in horizontal format? So 3 times 8 is 24, plus 5 is 29. We have 29/8, and then we're dividing by that 19/16. Now, if you remember, when you're dividing fractions, that's like multiplying by the reciprocal. So we're going to take 29/8 and multiply by the reciprocal on 19/16, which is 16/19. Now we actually see some common factors, or at least a common factor we could get out of here. How about 8? 8 goes into itself once. It goes into 16 twice. Then we multiply. 29 times 2 is 58. And 1 times 19 is 19. So we could write this as 58 over 19. If you do want to get a mixed number, we're dividing 19 into 58. That goes 3 times. You multiply, you'll get 57. Subtract to get the remainder, it's 1. So this happens to be 3 and 1/19. All right, that's it for this video. We'll see you in the next one.